All right. I just wanted to do one quick follow-up. Another question on conditional probability with our two-way table here. This is one, it's kind of a sad one a little bit, but it's actually kind of interesting. So it's related to cancer testing, cancer screening. And what you can see in this two-way table here is most people don't have cancer, thankfully, right? That's a big number, right? And then those that do have cancer is not very big. It's actually only 10, right? And so what this shows is that the test is pretty accurate, right? Like out of those 10 cancer patients, 9 of them tested positive, one didn't, right? And out of all those that didn't have cancer, I think that's 990, right? Out of those, most of those tested negative the way they should, right? But a few were kind of mistested. So, anyways, what this is saying is like, what is the probability that you have cancer given that you test positive? That's kind of the ultimate goal of this. And surprisingly, that you think that if you test positive, it'd be really likely that you have cancer, but that's actually not true in a lot of situations, even if the tests are really accurate. Okay, and it kind of the reason for it is most people don't have cancer. Okay, and so then when you test positive, you're most likely to be one of these people that was actually miscategorized by the test, like mislabeled by the test, more than you are to actually have cancer. So few people have it that there's a lot more wrong tests than there are people that test positive and actually have cancer. So we're going to do these calculations real quick. You can pause the video, try them on your own if you want. You'd be surprised that this one's not very high. Okay, so probability you test positive given that you have cancer. Remember that this is going to be your denominator. So here we're looking at only the cancer people. So that's just 10. And out of those 10 that have cancer, the ones that will test positive was 9. Right, so here's your 10 cancer people, and 9 of them tested positive, meaning the test is about 90% accurate. Okay, and similarly, given those that test negative, given that they don't have cancer, so here's my no cancer people, that's 990. Right, that's my denominator. Sorry for the poor handwriting. Do not know why I can't get this thing to work. 990. Okay, that's the denominator. And out of those 990, the ones that don't have cancer, the ones that test negative is the 891. All right, so out of these 990, 891 didn't have cancer. And again, that comes out to about a 90% accuracy. So the test is working pretty well, right? But even though that's true, if we do this, the probability you have cancer given that you test positive, well, here's our positive tests, right? So that would be 108 if you add those up. 108. Okay, and then out of those 108, the ones that actually had cancer was only 9, right? And if you look at that, right, here's all our positive tests, only 9 of them actually had cancer, right? Even though the test is 90% accurate, right? And it comes from there's so many people that don't have cancer that you're more likely to be one of these, what would be a false positive test where you don't actually have cancer. So, anyways, the chances that you have cancer here is only 9 out of 108, which is 8.3%. Okay, so what happens is if you actually test positive for cancer, at least for certain kinds of cancer, they'll often test you more than once, right? Because there's a good chance, actually better than 50% chance that if you test positive, the chance you actually have cancer is not that great. So it's 8.3% based on this data. And this isn't 100% representative because I think the test might be a little bit better than 90% accurate. But even at 90, 95%, they're going to test you multiple times just to confirm the result. So thought that was kind of an interesting real life conditional probability. And there's actually tons of conditional probabilities in real life. So that's it. We did conditional probability with two-way tables. Next up is to do it with tree diagrams. That'll be in the next lesson.